Hey everyone, thanks for tuning in. We have another workshop lined up. I'm Harpal, Sev Devrel, and today with us we have Vish from the Graph Foundation. She will be talking about what Graph is, how you can create subgraphs for your contracts. If you have any doubts, feel free to use the YouTube live chat, which is on your right. And if you're watching this as a recording, feel free to ask questions in the comment section. We also have a Discord group dedicated for this hackathon. Feel free to join the Discord server, and Vish is available there to answer your queries post the live stream. So, with that, Vish, over to you. Take over.
Thank you so much, Harpal. Hey everyone, super excited for the workshop today, and thank you so much for tuning in. We are going to be learning how to build decentralized GraphQL APIs using the graph, and these APIs are called subgraphs. So what we'll basically do is build an example API using the Zora smart contract, which is kind of like an NFT marketplace. So we'll be building an NFT API basically. But this is something that you could do for your existing Celo smart contracts as well, which is why I wanted to do this workshop for the hackathon so that if you're building a dApp and you're using a Celo smart contract, you can learn how to build a subgraph to start indexing and querying data from that smart contract. So before we get started, a bit about me. Hi, I'm Vish, and I'm a developer relations engineer at the Graph Foundation, as Harpal mentioned. And I mostly do this. I do a lot of workshops and hackathons. I focus on education, specifically subgraph developer ecosystem, and making sure that we're improving ways and avenues in which we reach out to our developers to educate them about how to build subgraphs and the entire developer experience around it. So that's mostly about me. And let's dive right into it. So I'm going to be dividing this workshop into two main parts. The first half will be me basically going through my slide deck, where I'll be talking about what the graph is, giving kind of like a 101 on the protocol, and then also going into the technicalities of subgraphs, like what exactly subgraphs are, how they fit into your Web3 stack, and then diving right into a live demo um, on how to build subgraphs. So let's get started. Um, let's talk about the graph. The graph is a Web3 indexing and querying protocol for blockchain networks like Ethereum and IPFS. And the graph community plays a prominent role in supporting dApp developers by making open decentralized data easily accessible with GraphQL. But to understand it in simpler terms, as an analogy, the graph does for open data on the blockchain what Google does for the web. So you can see it as a protocol, a data access layer that helps you index and query all of the data that is available on blockchain networks. And using the graph, anyone can build and publish open APIs called subgraphs that make data on the blockchain accessible. Now, with subgraphs as the main API layer, as you can see this, I love this diagram. It's very it helps us learn visually, and I love how it describes three layers and the three main layers in your stack when you're building a dApp. The first one is the UI layer. Second one would be the subgraph or the indexing layer, which is also the API layer. And the last one, the final one at the bottom you see is your contracts, like all of your app data or your protocol data that you want your front end to consume and display on your client. So with subgraphs as the main API layer that sits between your UI layer and your data layer, which is basically all of your data, decentralized data from smart contracts, the graph is quickly becoming a default part of the Web3 stack. And subgraphs with that are now becoming a Web3 standard for indexing and querying blockchain data. But I get this question often, like, where does the graph come into picture? There are a lot of developers ask that there are so many other solutions for what the graph is currently doing. And I just want to paint that picture for you folks so that you understand how and why you should be using the graph exactly. So this is here is the scenario. The reason why graph is the easiest way to query open decentralized data is because we live in this data-driven world where our data is stored across huge storage networks and blockchains. And these blockchains, these networks get large number of transactions per day. Think of the biggest number you can think about in terms of how many transactions have been on Ethereum so far. And there you have it. You can start imagining how many blocks we have and how many transactions per block we have. And if you start thinking about all of that data that is on the blockchain, it's huge, it's humongous. So when developers are building applications, especially decentralized applications, they need index data for high performance and great superior UI UX for their users. And with all of the data that is currently on the blockchain, um, it is becoming increasingly difficult to index and query this blockchain data for your dApps. So, as a solution, developers have to build proprietary indexing servers, and writing these servers is expensive, it is error prone, and it is not practical for three main reasons, which are the first one is that if you build a indexing server yourself, um, it means that it's a single point of failure. So if one node goes down, everything goes down. Like that, if that server goes down, everything in your dApp, it goes down in production. The second point being that it is centralized and it goes against the entire ethos of decentralization. And then the last part being that it is, of course, extra infrastructure to manage, which means like if you're building your own indexing server, it needs engineering and hardware resources. It is costly, it is error prone, and of course, disrupts the core idea of decentralization, which is why the graph comes in. And the graph provides a global and open API um, that caters to a lot of different kinds of use cases like NFT marketplaces, galleries, and metaverses, music and video, social and comms platforms, DAOs, governance, anything that you can think of. The graph can power that in production using subgraphs. And the reason why I'm saying that the graph is the easiest way to index and query blockchain data efficiently is because it's not just a global open API. It is a transparent and open network now, a decentralized network, which consists of a different which consists of various other participants that make up the entire decentralized and open network. For example, there are subgraph developers, there are people who curate on um, different subgraphs, so just so that the indexers know which kind of subgraphs to index. And then, of course, as I mentioned, indexers, these are the people who, these are the participants who index your subgraphs. So that kind of makes up the entire transparent and open network. And not to forget, it is decentralized and robust because it is built on top of GraphQL, which comes with its own benefits, like an entire suite of developer experience benefits. For example, GraphQL is real time and instant in terms of like how it serves the data through one single endpoint to your client, your front end client, and it gives you exactly the data that you asked for. And you like imagine asking for 10 different kinds of um, you know, if you want to request different kind of data with the REST API, you would have to make 10 different requests or calls to your API. But with GraphQL, there's a single endpoint, and in a single query, you can ask for all of the data that you need, and you'll get back exactly what you asked for. And so the Graph APIs are built on top of GraphQL. So of course, it's going to be a great developer experience. And the graph is powering DeFi. DeFi dApps in production that are querying on-chain data like trades and exchange volumes, total body, borrowed, supplied, staked, total value locked, and other things like that. So all of these cute little icons that you see, these are all of the DeFi dApps that the graph is powering in production currently. And not just that, but the graph powers other applications like websites like CoinGecko and CoinMarketCap, if you know. And in the space of NFTs and DAOs, there's always Foundation and Juicebox DAO that you might know of, and also very famous in DeFi, Synthetics and Uniswap, all powered by data from the subgraphs. And currently, there is two ways as to how you can deploy your subgraphs, your APIs. The first one is the hosted service, and the second one is the decentralized network that went live just last year. So the decentralized network is a network of the participants that I mentioned, and then the hosted service is a centralized service that we initially started with and went live with, just so that we could achieve product market fit and also test out before we go in production. So we've just started migrating dApps to the decentralized network, and 350 plus dApps have been migrated, dApps dedicated to decentralization, as you can see in the icons below. And the hosted service, although, has been supporting subgraphs for over 4 years now, so, dApp developers and subgraphs for over 4 years now. And it has done that through 39 different chains. So the Graphs hosted service currently supports all of the chains that you see and beyond. And Celo is included in that. So with that, we've understood what the graph protocol stands for, what its mission is, what it does, and how subgraphs fit into your Web3 stack and what subgraphs actually are. So let's see some code, and I will quickly talk about what we're building, but I need to switch back to my desktop so that we can see the VS Code and the browser tabs as well. Just a second. Oh, I don't think I have the permission to share the entire screen.
Um, you should have. I think so.
I guess I need to give permission to StreamYard for this. Just give me a second.
Yeah, sure. No worries. While that is happening, feel free to ask your questions. Or just paste the link to the Discord server that you can join to ask more questions, post this live stream. As we move towards the end of the hackathon, we are already midway. I am sure you are following the weekly commit schedule, which is 3 commits per week. Um, please don't forget to follow the schedule. It is also a requirement.
Hey, sorry, it quit my Google Chrome.
Yeah,
Weird. Sorry. What? Let me test out if I can share my desktop now. Okay, awesome. This works. All right. So we will get started with a quick live demo. And so just wanted to get into a few things before we get started with the live demo, and we'll learn how to build a subgraph. Two things. The subgraphs that we can be built using two different services on the graph protocol, using the graph protocol right now. The first one is the hosted service that you see right here that I have open. And then the second one is Subgraph Studio. So let me open both of them and give a quick overview of what the difference is. So this is the hosted service, and that's the centralized service that I talked about. And I wouldn't say centralized, but it is being currently managed by one of the core developer teams at the Graph called Edge and Node. And we have planned migrations from the centralized service, which is the hosted service, to the decentralized network. And to deploy subgraphs on the decentralized network, you need to build subgraphs using the Subgraph Studio. As you can see here, I have a few subgraphs in my dashboard. Um, and if you would like to deploy a subgraph, like build and deploy a subgraph using the hosted service, on the hosted service, you would need to use the hosted service. Now, the reason why we are going to be using the hosted service today is because Celo is not yet live on the decentralized network. And so if you want to use an existing Celo smart contract and deploy on Celo, then you would have to use the hosted service. So I wanted to teach you how to use the hosted service instead of the Subgraph Studio. But if you want to deploy your Subgraph using on Ethereum mainnet or something, then you can always use Subgraph Studio because we're live on that network. So let's get started. The first step here would be to add a subgraph. And this is what it looks like creating the subgraph. That's the first step. Let's name it Celo Hacks. Okay, it's available. And subgraph title, Celo Hackathon, example, subgraph. And I will quickly hide it from the Graph Explorer because this is just for a demo and I don't want other people to see this example on the Explorer, the Graph Explorer. So when you click on create subgraph, it is going to show you this piece of information, like this flow. So the way we can understand the journey of building a subgraph can be divided into three parts. The first is installing the Graph CLI, which is just a one-time thing. You wouldn't have to install it again and again. Once you've installed it using either npm or yarn, you're good to go. And the Graph CLI comes with a lot of different utility commands that you can use to then design and authenticate and deploy or test out your subgraph. So that is the second part, which is the init. The init section is the phase or the step in which we will be initializing or scaffolding our subgraph using the graph init command. And then the deploy part is the last step, which in which we authenticate our subgraph and deploy it on the hosted service. So before we get started, for the Zora NFT example, I will be referring to this guide. Although a quick disclaimer that this guide refers to the Subgraph Studio. So if you want to learn how to build a subgraph using the Subgraph Studio and deploy the subgraph on the decentralized network, then this guide would be suitable for you. There's not a lot of difference between um, deploying a subgraph, like the process of deploying a subgraph on the hosted service versus a decentralized network. The only difference is in a few commands here and there, which is why I will be referring to this guide, but I will be copying the commands from here. I guess we can go ahead and close this tab because that's the studio. And so the first step, I want to talk about a few prerequisites, which is you would need to have Node.js installed on your machine, and then a MetaMask wallet. But the MetaMask wallet isn't required for the hosted service. That's only something that you need if you are working with the Subgraph Studio. So let's go ahead and get started. Also, some knowledge of TypeScript or JavaScript and GraphQL would come in handy because you will essentially be writing mappings, which are in assembly script, and then also writing GraphQL schema, which we'll talk about just in a bit. So if you have prior knowledge of GraphQL and at least know how to write some basic queries, that's going to come in really handy, and it would provide you the best experience once you come back to this workshop and try it out for yourself. So I would recommend going through a quick overview of what GraphQL is, how to write out a few queries, and you can always use something like the GraphQL Playground for testing it out. So I already have npm installed. I already have the Graph Protocol CLI installed on my machine. So I'm going to go straight in the init command. And the good thing about the documentation on the Subgraph dashboard here right now is that all you need to do is copy this command because it has been crafted specifically for your subgraph. So for example, your subgraph slug is cellohacks, which is basically your subgraph name. This command, if you've copied it here, and this is my VS Code that we'll be working on. So if you do that and paste it, you'll see that it has written cello hacks, like already included that. So all you have to do is copy and paste that command and get started with it. Now what this does is it initializes or scaffolds a subgraph, kind of like a bare minimum of what you would need, bare bones of what you would need to get started with some code. So I'm going to go ahead and select Ethereum, and because the subgraph, the contract that I will be using, the Zora NFT smart contract, is the smart contract that is deployed on Ethereum mainnet. And then just select defaults. The contract address here is the contract that you will be using. So I'm using the token or the media contract in the Zora NFT smart contract. So I'll be doing that. Oh, oops. Not sure how. Let's try it out once again. Let's see what's wrong. Cello hacks, Ethereum, create subgraph cello hacks, select mainnet. Oh, contract address. So that is the contract address we need. By mistake, I entered the contract name. So if you search for Zora NFT smart contract, this is the Zora developer documentation, and this is the smart contract that we will be using for the NFT data. And so I'm going to go ahead and copy and paste that, and it's fetching ABIs from Etherscan. So now the contract name is the one that I mentioned earlier, which is token, enter. And so once you enter this command and enter all of the flags, which is the basic information to configure your subgraph, it will start scaffolding your subgraph, as you can see here right now. So once it's done doing that, your init process has already been completed. Your initialization will be completed, and it will create a new subgraph called cello hacks. And the next step would then be to design the subgraph. So, oh, okay. Cello hacks. And so let's go ahead and open in desktop. And here it is. So let's open the folder. And as you can see here right now, this is the basic folder structure for a subgraph. So irrespective of whether you deploy it on the hosted service or the decentralized network, all of the steps from here on are going to be pretty similar. And the way you design and deploy a subgraph is going to be exactly the same. The only difference would be that for the hosted service, you're using the hosted service, and to deploy on the decentralized network, you will be using the Subgraph Studio. So let's go ahead and learn a bit about the main components of what builds up a subgraph. The first one is the subgraph.yaml file that you see right now. This is your typical YAML file or the configuration file, um, which describes different things about your network that you're deploying on or using, where your data source is deployed on, which is Ethereum mainnet, your token, your contract name, which is token, your contract address, which is described here. You can also define a start block so that you can make sure that it's not the genesis, it doesn't start indexing from the genesis block. So let's go ahead and do that. Open up Etherscan. And if you search by the contract address that we're using, you'll see that you can always go to the last block right here. And then this is the block number that we want to be able to define it right here. So I'm going to define it as start block. And what this will do is, instead of starting and indexing from the Genesis block in your smart contract, it will start indexing from this particular start block, which is the last one. And that kind of helps with the syncing speed. So yeah, this is basically our subgraph.yaml file, and we'll make some other changes in here as well. But before that, let me quickly go through a few other components. So there are two other main parts of a subgraph. The second one is the schema.graphql file. Now this file, if you're aware about GraphQL and GraphQL schemas, this lets you describe all of the data that you want your subgraph or your GraphQL API to query onto your front-end client. So for example, from this smart contract, I want to index and then query to my client two kinds of data, which is the token data and the user metadata. Then I would need to define two different types, which is the type token using the at entity directive, and the type user, again, using the at entity type directive. Now, the reason why we use this at entity directive is it will help us define some top level fields for each of the data, and then define the type, the data type for each of those top level fields, so that we can then query it using our GraphQL API. And we will define our schema just in a few minutes. But lastly, the third main part of a subgraph is the mappings file. This is a TypeScript file. If you see mappings, a mapping.ts, and what we will be doing here is defining some or writing some event handlers in assembly script that will help us map all of our business logic that we want to be implemented every time we start listening to events from the smart contract. So as soon as our subgraph starts indexing the smart contract and the smart contract emits the events, we want to write some kind of code or some kind of function that will be executed to handle that event. And that's called an event handler that we will be writing in our mapping file. So that's it. That's the three main parts that we'll be editing in order to be able to define our subgraph. So let's go ahead and do that. The first thing that I already defined the address and the start block for our smart contract. So the second thing that I'm going to be doing is get rid of those entities and define my own entities, which are token and user. And as I mentioned, entities will be defined in this GraphQL schema. And this is basically all of the data that you want your subgraph to start querying. So that is token data and the user metadata. And then lastly, in the YAML file, we will be defining a few event handlers. So I don't want all of these. I will just, for the sake of this demo, I will just keep two event handlers, which will be dealing with two events, token URI updated and transfer event. So the token URI updated event is a basic event that is emitted from the smart contract whenever the URI or the link of a token or an NFT has been updated. So that's and so this handle token URI updated is the handler that we would then write in our mapping file to be able to handle this event whenever it is emitted. And similarly, there's another transfer event that is emitted whenever a transfer event happens on the smart contract. And the scenario here is that whenever a new NFT is being minted or the owner of an NFT is updated, that's when a transfer event happens. And so for that, we will be defining handle transfer event. So that's all the changes that we will be making in the YAML file. Now moving on to the schema.graphql file, we will be defining two basic types, which is type token at entity directive, and then the other one will be type user, again at entity directive. And so in this, we will be defining all of the fields that will be contained in the token and the user types. And I'm gonna go ahead and close up this, copy the GraphQL schema from here that has already been defined for our example in the guide. Um, and so here it is. If you see the token type, there are some fields called ID, token ID, content URI, which is string, which is the link for the token. There's the metadata URI, which is the link to the metadata, created at timestamp. So if there's a timestamp time at which the token is being created, that is begin. We're also defining two objects called creator and owner of type user, and user has already been defined here. So it will take all of the metadata from here and then declare it as a top level field in the type token, so that when we want to query token and creator and owner data, creator is basically the user that created a particular NFT, and owner is the user that owns that particular NFT. And owners keep changing, creator always remains the same. And in the user metadata, we will be defining two relationships here using the at derived from directive. And there are two different ways in which you can create this relationship. The first one is create an array for many-to-many relationship. And then there's also this at derived from directive, which if you know GraphQL, it's a GraphQL concept using which we can make some performance enhancements. It's better in terms of performance. Wouldn't be going too deep into that, but if you have specific questions around why, I'd love to explain it async on Discord. So feel free to reach out to me for questions typically around GraphQL and the directives that we've used here. But basically what we're doing here is creating a relationship between token type and owners and creators. So for tokens, we're creating a relationship between the users that own, like owners that own tokens. And then the second relationship is creators that have created tokens. So that's it for our schema.graphql file, which is our GraphQL schema and all of the data that we want our subgraph to start querying. And then last step here would be to start defining our event handlers. But before moving on to that, what we need to do is there's a command called graph codegen that we need to execute before we move on to our mapping file. And let me quickly explain what the graph codegen command does. So the graph CLI has a TypeScript library that it gives out of the box, and what that does is it comes with the graph codegen command. So once you've executed it, it gives a few functions that we can use, and it's you can see it in the generated file. So all of these helper functions, we don't need to define them, but it comes out of the box with the graph codegen command, and then we can use that to create the mappings here, and we will be importing that from both token and schema. So yeah, let's go ahead and execute that. So as you can see, it says the types have been generated successfully. So this is our queue to be able to go ahead, go into mapping file, get rid of all of that code. And we have a few mappings that have been already defined for us here. So I'm gonna, for the sake of this demo, I'm just gonna use those mappings. Copy that and paste it here. Now let me quickly explain what's happening right here. So we've imported the helper functions that we get from the graph codegen command upon executing the graph codegen command, and the two main files are token and schema that have been generated in the generated folder after executing that command. And so we're importing all of those helper functions from those two files. And what that does is the token file has helper functions that help us interact with the smart contract itself. And the way we interact with the smart contract is by reading data from the smart contract. We won't be able to write it on the smart contract, but we will only be reading it. So all of the helper functions that we will be using will help us read data or load data from the smart contract. And that is included in token file that we're importing from. And then the second one is the schema file. Now, this is the file which has all of the helper functions or the TypeScript types that help us define functions that will help us interact with the graph node itself. Now, the graph node is this um, database which then saves all of the data that we need from the smart contract. It saves it to the graph node once we index it using our subgraph, and then that data will be used to be queried and served to our front end client. So all of the helper functions in the schema file are they help us read data from the smart contract and then read data from the database, the local database called graph node, and also write data to the graph node. So this is unlike the smart contract interaction. This is a two-way street. We're able to read data, but also write data on graph node. So that's about the two main files that have been generated using the graph codegen command. Coming back to the event handlers. So we're dealing with two main event handlers, which is the handle transfer function and the handle token URI updated event. Now, I've already described, explained what these events do whenever they're emitted. And so in the case of, let me quickly go through the smaller one first. In the case of a URI of an NFT being updated, what we want to do is we don't care about what the old URI was. So we are not loading the old URI, but we're only reading the data of the current and then like the newly updated URI from the smart contract, and then saving it. As you can see here, token.save, where we're loading it from the smart contract and then we're saving it to the graph node. And that's what basically this code here does. And going through the handle transfer event, the business logic here, what the basic idea here is that it is checking, there are two scenarios, right, to the transfer event. The first case is that an NFT already exists. And in case that it exists, then the scenario is that the ownership of the NFT is being transferred. So there is an if condition that we're writing here. So if the NFT is new, if the token exists, then what happens is that it already retrieves the owner, the new owner, and then saves it to the graph node. But in case that the token does not exist and is being created, a new token is being minted, then it will retrieve the new user data and then the token data and then save it to the graph node, creating a new user here as well. So that's what this code does. And we're going to go ahead and save both of these both of these events that we've written. And the last step here would be moving back to the documentation here. Once we've defined the data here, just a quick recap that we defined the configuration file, which is the YAML file, made a few changes, defined the start block, entities, and the event handlers that we want to write. The second part was writing the schema.graphql, like the GraphQL schema, and the describing the data that we want our subgraph to index. And then the final part was running the graph codegen command, generating the TypeScript types, and defining the event handlers finally in the mapping file. So those are the three things that we did to define our subgraph. And finally, once we've already done creating our subgraph, the last step would be to authenticate and deploy our subgraph. The reason why we want to authenticate is we want to connect our local um, subgraph code that we see here from our machine to authenticate it using this access token and connect it to our subgraph dashboard here. So we will be authenticating our subgraph using this command. And the final step is deploying. So currently, if you see on the dashboard here, it is undeployed. And once we run the deploy command, if everything is all right, this should work. And the build is completed and the subgraph has been deployed. So there are two main endpoints that our subgraph gives. As you can see, the queries endpoint, which is to be able to query the subgraphs, and there's one for the WebSocket, the subscriptions, which is here. And our subgraph has basically been deployed. So if we refresh this, this should, yeah. So it shows, as you can see, that this has been synced and the subgraph has been deployed. And you see all of the details about the subgraph, the network, which is Ethereum mainnet, last updated a few seconds ago, created 24 minutes ago, all of the entities that are included in it. And this is the subgraph ID, and this is the query that you can use to then um, using Apollo client or any other front-end client, GraphQL client, you can use this query to then connect your subgraph to your front end and start querying it to your UI, your client application. So before we conclude this, we're going to quickly go ahead and test out our first query. All of this code has run successfully, and what that means is that we are now able to index and query data from our smart contract. So an example query has already been written out here, and what that does is it wants to request the first five tokens and the corresponding user metadata from the smart contract. So upon running the GraphQL query, as you can see, we have been returned all of this data as a response to our GraphQL query. And in reality, what this would look like is once you've connected it to your front end, all of this data in a single request would have been available to your made available to your front end application. So that is basically it for our subgraph live demo. And I think my slides got closed the first time when it crashed. I want to quickly go back to my slides. Um, and yeah, so that was our demo. And if you want to go get involved and want to join the Web3 movement, um, our official website is thegraph.com, and our documentation. You can learn more about what subgraphs are and how to build them or how to query existing subgraphs. You can go to thegraph.com/docs and go through the documentation there, or get connected with us to interact with and keep up with the latest news and announcements around the Graph Protocol by following us on Twitter at Graph Protocol. And of course, you can join the community and interact with our amazing community members, ask questions there, seek support from the team, share what you're working on in our Discord, and the invite is on thegraph.com/Discord. So that's basically it for my demo, but I forgot to include the bounties slide in here, but the graph is offering bounties worth $1,000 paid in USDC um, for in two main categories. The first one is if you build a new subgraph for your Celo smart contract, similarly the way I did it for my NFT smart contract. And then the second category is if you query an existing subgraph for your smart contract or your DApp, then that's the second category. If you have any questions regarding any of these categories or how to get started with subgraphs, how to submit for the bounty, feel free to reach out to me on Discord, the hackathon Discord. You can just tag me at Wish, and I would be happy to answer your questions. I've also in the the developer resources channel, I've also shared a pretty cool resource that I've recently created, which is called the Graph Cheat Sheet. And whatever I covered in this workshop, um, this is like a very compact version of all of that information and all of those commands that you would need to run to be able to build a custom subgraph or query an existing subgraphs, which are the two main categories for the bounties. So if you want to access this, feel free to go to the hackathon developer resources channel, and you should find a message which includes the subgraph cheat sheet. So that's it about my demo, and thank you so much.
Awesome. First of all, thank you for taking out the time to do the workshop and educating the participants about the graph protocol and building subgraphs for the contracts. And yes, are we taking any questions, Wish?
I would love to take questions on the Discord. I'll be hanging out there. So if the users have any questions, the participants have any questions about the bounties specifically, or how to get started with subgraphs or the graph, would love to answer them there on Discord.
Awesome, great. So, yeah, all the links to the cheat sheet, all the resources, all of them would be available in the description of this recording, and Wish is available as well in the Hackathon Discord. So feel free to drop your questions there, and also feel free to drop your questions in the comment section. I will be periodically reaching out to the comment section and taking questions here as well. Yeah, thank you, Wish, for doing this workshop again, and thank you everyone for joining. Have a great day.
Bye, everyone. Thank you.